What?
Okay, so this problem says that Marco is planning a snack of graham crackers and blueberry yogurt to provide at the school's track practice. Because he's concerned about health and nutrition, he wants to make sure the snack contains no more than 720 calories and no more than 20 grams of fat. He also wants at least 20 grams of protein and at least 24% of the daily recommended value of iron. The nutritional content of each food is listed in the table. Well, it's below on your paper, but I moved it on mine. Each serving of yogurt costs 30 cents, and each graham cracker costs 8 cents. What combinations of servings of graham crackers and blueberry yogurt should Marco provide to minimize the cost? So our objective has changed. Yesterday, our objective was to maximize profit. Today, our objective is to minimize cost. So when we plug in our test vertices, today we're going with the one that has the lowest cost. Does that make sense?
Yes.
Okay, so instead of giving us the information in paragraph form, they've given us most of our numbers like we would see if we looked on the back of at the nutritional label. So they have it in a nice table form. So we have graham crackers and blueberries, the servings, the calories, the fat, the protein, the iron. Okay. Let's see if you guys can fill in that chart without me helping. Identify your variables and fill in the chart. Take just a moment.
Isn't it the
What now? It's not possible to have a negative cost? Well, I guess that's all colors and tape. Okay, so what does it tell me about calories for a graham cracker?
60.
60. So if we called graham crackers X and yogurt Y, that makes sense, Y for yogurt, this would be 60X, wouldn't it? What about calories for yogurt?
120.
120. So this would be 120 Y. And altogether, how much did it tell us over here in the paragraph? How many calories at most or at least?
720.
Okay, 720. And that's at most. So this would be less than or equal to 720. So we just came up with one of our constraints. 60X plus 120Y is less than or equal to 720. All right, talk to me about fat.
2 grams.
Okay, 2 and 2 and max or min. Excuse me, greater than or less than? Less than or equal to? 20. So that's my second constraint. 2x plus 2y is less than or equal to 20. Protein. Tell me about protein for a graham cracker. 2. All right. Tell me about the grams of protein for yogurt. 5y. Good. And is this going to be less than or greater than? Greater than or equal to And what is our constraining value here?
20.
20 again. So, but this one's going to be shaded differently, isn't it?
Yeah.
It certainly is. Okay. Iron. Percent. Okay. I got percent, and percent, don't I? So since they're all in terms of percent, can I just drop the percent? Yes. So this would be 4x and 2y is greater than or equal to 24. 4x plus 2y is greater than or equal to 24. There are my constraints. Now, this says profit equation. Wrong, wrong, wrong. What should it say? Cost. And when we think about this, we are going to try to minimize cost, aren't we?
Yes.
All right, tell me about the cost of a graham cracker.
8 cents.
8 cents a cracker, and the cost of a yogurt. 30 cents. So this would be, the cost is equivalent to 8 cents per cracker plus 30 cents per yogurt. And I identified X as graham crackers and Y as yogurt. All right, graph the first two and then shade a little below them. And these are both, when you plug in 0, 0, it's going to make a true statement. Oh, what did I leave out? Can we have a negative number of graham crackers?
No.
So X has to be greater than or equal to 0. Can I have a negative number of containers of yogurt? So Y has to be greater than or equal to 0. So I'm still in the first quadrant. No other quadrants necessary. All right. Time to graph. Please graph. Did you do your T-charts? You know what your intercepts are? Huh? I'd figure those out first. And then I'd start worrying about.
Bless you.
Thanks. Do I count by ones? Good. Yeah.
On, oh, it's 16. You don't have to do the whole problem.
If you get to this part, you can stop.
Whoa.
Have you grabbed it?
Yeah.
Okay. See on my t-shirt? Oh, okay. That's just here at 0, 0 though. So it's just in here. Plot these 2 points, connect the dots. Plot those 2 points, connect the dots. Okay, so what I did was I did the 2 less than that were in blue, so I know I'm below both blue lines, and I graphed the 2 greater than in red, so I know I'm above on the 2 red lines. So this is my feasible region in here. Did y'all get that?
I did that backwards because that's the only area that's not showing in
For the 2x plus 5.
Okay, so I got test vertices. Here they are. 1 there, 1 there, 1 here, and 1 there. Okay, so if you need to check your shading, check that now. You sure did. That's very interesting.
Yes, because I have the same mark.
If you stared at it for a long time and closed your eyes, it would look right.
Maybe I'm just like a higher level of math than like my brain can even handle.
Okay, that's it. Okay, so my test vertices are the points 5, 2, 4, 4, 8, 2, and 10, 0. So if you guys will test those by plugging them into our cost equation, which we are trying to minimize because our objective function is to minimize cost. You missed the 6. Oh, I see the problem. Okay, you said you were counting by ones, right? But we put this first one in. You went up by 2. If you count by ones, it has to be consistent all the way up. So, okay, does that make sense?
Yeah, but I reckon right?
You got that here, right? Yeah. You gotta make sure if you're counting by ones, like if it's 1 in between these, it has to be 1.
Yeah, and if I move it over, it would have been 6.
You moved it over.
Yeah.
Okay, so did you get $1? Okay. What if we got 4 graham crackers and 4 servings of yogurt? What would it be?
$1.42.
$1.52. What about 8 grams and 2 servings of yogurt? $1.24. What about 10 grams?
Oh,
80 cents. Aw, man, we're not getting any yogurt, are we? Marco
I don't even like it.
should serve 10 graham crackers per person. For a cost of 80 cents per person. Okay, if you're just really stinky at intercepts, one, you really need to practice because we should be good. But we could have written these in slope-intercept form. This equation would have been y is less than or equal to negative 1/2 x plus 6. And that wouldn't have been hard. This would have been y is less than or equal to negative 1x plus 10. This would have been y is greater than or equal to negative 2/5 x plus 4.
Oh, I see how you get it.
And this one would have been y is greater than or equal to negative 2x plus 12. But you should be proficient at all methods of graphing. So I don't want you to just be dependent on slope-intercept. I want you to be just as happy with graphing using your x and y intercepts. Okay, there are 2 on the back for you to do.
Yeah.
Now, before you get started on those, sometimes when we have a minimize problem, we can actually get a very interesting looking region. We can get a region that might look like this. Let's say we have these 2. And the shaded part could be out here, going on forever.
To minimize?
This is called an unbounded region.
Unbounded?
And we're only going to get an unbounded region. See, it's not bounded on this side. There's no boundary over here. So we would test this point, and this point, and that would work if our objective function is to minimize.
What if it was to maximize?
If it's to maximize, then there would be no solution if it's an unbounded solution.
For no solution. Or unbounded.
Okay, there are solutions to both the ones I give you tonight, though. Okay, if you'd like to use like the chart, like we did, if that's helpful for you, you can set one up. I won't grade the chart, but if it helps you, you're welcome to do that.